Hi students, today we are going to see about the chapter 7 coordinate geometry. Let me recall these 2 points which we have learnt in the previous class. The distance of points from the y-axis is called x coordinate or axis. So let's consider it is in a y-axis. If any point you choose just away from the y-axis, then this point is called a this distance is called a x-axis. We'll call it as also x-axis, and this point is a x coordinate or abscissa. Next, the distance of the point from the x-axis. Distance from the point is x-axis. It is called y coordinate. So any point, if you take this length, and this is called as a y coordinate or ordinate. So anywhere you can take this distance will be always the y coordinates. Right? So in this chapter we are going to learn about a distance formula. So distance means you will find a distance between any 2 points, that is the shortest distance between any 2 points, right? So let me draw that line, the distance between these 2 points as a line in the coordinate planes, right? Coordinate plane is in the xy plane. So let me call this point as a some point here, right? Some point from this is a x and this will be the y. So let me call it as an x1 and y1. Just generally I'm considering x1 comma y1. We can draw it anywhere, right? So the same here we will be obtaining a x2 I will choose here, and the line at the point here I will do as a y2. So this coordinate will be a x2 comma y2, right? Now we need a distance between these 2 points. This is a straight line. You can see if now I am trying to draw a parallel line to the x-axis from this point. From this point I am drawing a parallel line to the x-axis. Same from this point parallel to the y-axis. You can see that it is meeting at a 90 degree because these both are perpendicular. So we are drawing a line parallel to x-axis, again the parallel to y-axis. Again these two lines will be the perpendicular. Now we can see it's a right angle triangle. We can use a Pythagoras theorem to know the length of this line, right? So let me call this point as a P, and this as a Q, and this as a T. So now we need a distance between P, Q, right? So by the Pythagoras formula, PQ square, that is hypotenuse square, is equal to sum of square of other two sides. Other two side is here is a PT square and TQ square. PT square plus TQ square. So what is the length of the PT? Length of the PT we can easily find, right? This length of the PT is nothing between the distance between these 2 points. So this full length is x2 and this full length is x1, and this length will be the x2 minus x1, right? Is it clear, right? Where the number 1, 2, 3, 4, 5, 6, 7, 8, 9, if you are playing like this, if this point is a 5 and this point is the 9, and distance between these two is a 9 minus 5, that is the 4, right? 1, 2, 3, 4, 4 is the distance. So generally I consider as a x1 and x2, so is a x2 minus x1. And what about the TQ? The same. The total I consider as a y2, the length, and this one is the y. So this length will be the y2 minus y1. So PQ square is equal to x2 minus x1 the whole square plus y2 minus y1 the whole square. Actually it is a PQ square. We need the length of the PQ, right? Not a length of the square. So let's take square this side, it will become a square root. So PQ is equal to square root of x2 minus x1 the whole square plus y2 minus y1 the whole square, right? So here we go for the problem. Find the distance between the following pairs of the point 2, 3 and 4, 1. So first coordinate we will consider it as a x1, y1, and second coordinate we will consider as a x2 and y2. So we have to find a distance. So distance formula is square root of x2 minus x1 the whole square plus y2 minus y1 the whole square, right? Clear? So distance I just written as a d. So x2 is nothing but 4 minus 2 the whole square. 4 minus 2 the whole square plus y2 minus y1 is 1 minus 3 the whole square. 1 minus 3 the whole square. Square root of it. right? Then the 4 minus 2 is the 2 square plus 1 minus 3, was 1 minus 3 is a minus 2 the whole square. So 2 square is the 4 plus minus 2 the whole square is also a 4, square root of 4. So square root of 4 plus 4 is nothing, just square root of 8. Square root of 8 we can write it as a 2 square root of 2, right? 2 into 2 into 2 is the 8 and square root of 2 is. So distance between the 2 points is the 2 square root of unit. At last you have to write distance between the given point is 2 square root of 2 units. Unit is very important, right? Because basically it's a distance, it doesn't given a meter or centimeter or kilometer, just a unit, so we consider it as a unit. So here we go for the next problem. Determine if the points 1, 5, 2, 3 and minus 2, minus 11 are collinear. Collinear is nothing, just the straight line. Collinear, you can see just a straight line. The 3 points containing in that straight line, that we have to prove, right? So let me consider this point as an A and this as a B and this as a C. Then if it is a straight line, we can say that AB plus BC is equal to AC, right? So that's what we are going to check. If any 2 points if we added, whether we are getting the longest length. So let me consider the point AB 1, 5. Just I am giving the name for the coordinate. You can give any variable, any point, capital, any letters, right? So first I will find a distance between the AB. First I will find a distance between AB 1, 5 and B 2, 3. So here this one will be the x1 y1 and here x2 y2, right? So with the distance formula, the AB distance between the AB is equal to square root of x2 minus x1, that is the 2 minus 1. 2 minus 1 is 1. So 1 square plus 3 minus 5. 3 minus 5 is a minus 2. Minus 2 square is a 4. Right? Just I written directly. So square root of 1 square 1. 1 plus 4 is a 5. So the value of AB is square root of 5. So next I will find a distance between B and C. So BC is equal to, so first we will write a coordinate. So B, while taking a BC, this one will be the x1 and this will be the y1, this will be the x2 and this will be the y2, right? X2 minus x1 minus 2 minus 2, x2 minus 2 is a minus 4, right? Minus 4 the whole square plus y2 minus 3 minus 11 minus 3 is a minus 14, right? So 4 square is a 6, minus 4 square is a 16 plus minus 14 square is a 196. 14 into 14 is a 196. So if we add, we will get a 212, square root of 212. So square root of 212 we can write it a 4 into 53, right? 4 into 53 is a 212. So the 4 we can write as 2 into square root of 53, right? So next we will find the distance of AC. So A means 1, 5 and the C point is minus 2, minus 11. So it will be the x1 y1 and it is a x2 y2. So AC, the distance of AC is equal to square root of x2 minus x1. Minus 2 minus 1 is a minus 3 square plus y2 minus 11 minus 5 is a minus 16 square. So minus 3 square is a 9 plus 16 square is a 256. 16 to 16 is a 256. If we add, we will get a square root of 265, right? So can you say if we add the 5 plus 2, square root of 53 will become a square root of 265? Never, right? So since AB plus BC is not equal to AC, therefore the given points are not a collinear. Clear? If it is equal, then we call it as a collinear. So here we go for the next problem. Name the types of quadrilateral formed if any of the following parts and give reason for your answer. So we will define the quadrilateral by its side, right? Length of the side. If all the sides are equal and diagonals are equal, square. If opposite sides are equal and diagonals are equal, they are rectangle. So like that, right? So let me consider there's a 4 point. If you draw, sure, if we connect and we will get a quadrilateral like this. Let it be a B, C, D. Let me choose this as an A, B, C and D, right? So let me find the distance between the A and B. So for A coordinate is a -1 comma -2 and B coordinate is a 1 comma 0. So distance of an AB is equal to square root of 1 minus of -1 is a 2, right? 2 square plus 0 minus 2, it's a -2 square. Minus into minus plus will be there, right? 2 square is equal to 2 square is equal to 4, 2 square is equal to 4 plus 4 is equal to square root of 8, which is equal to 2 square root of 2 units, right? And let me calculate the length of the BC. So B point is 1 comma 0 and C point is -1 comma 2. So length of BC is equal to square root of -1 minus 1 the whole square plus 2 minus 0 the whole square, which is equal to square root of -1 is a 2, 2 square is a 4, plus again 2 square is a 4, and it's equal to root 8, which is equal to 2 square root of 2 units, right? So next point we will choose the CD. So C is a -1 comma 2 and D is a -3 comma 0. So distance between the CD is equal to square root of -3 minus of -1 is a +1 whole square plus 0 minus 2 the whole square is equal to -3 plus 1 is a 2, 2 square is a 4 plus 0 minus 2 is a -2 minus 2 square is a 4. So square root of 4 plus 4 is a square root of 8, which is again 2 square root of 2 units, right? So finally we will find a length of the AD. So the point A is equal to -1 comma -2 and D is equal to -3 comma 0. So distance between the AD is equal to square root of -3 minus into minus plus, so +1 the whole square plus 0 minus into minus is 2, so 2 the whole square. So -3 plus 1 is a -2, -2 square is a 4, plus here the 2 square is a 4, square root of 4 plus 4 is the square root of 8, square root of 8 is nothing, 2 square root of 2 units. Clear? It clearly shows that all the sides are equal. But to prove it is a square, we need diagonals is also equal, right? If simply we get all the sides are equal, there's a chance it to be a rhombus also. So we can decide it is square or rhombus by finding the diagonals. Just diagonal. Find the distance between AC and distance between BD. If that diagonals is also the same, then it is a quadrilateral. So first let me find an AC. So A is equal to -1 comma -2 and C is -1 comma 2. So distance between AC is equal to square root of x2 minus x1 minus 1 of -2 minus is a +1. So -1 plus 1 the whole square plus 2 minus into minus is a +2. So 2 plus 2 the whole square, which is equal to square root of -1 plus 1 is 0. 0 plus 2 plus 2 is a 4 and the 4 square is a 16, which is the square root of 16. Square root of 16 is equal to 4 units. So here we'll consider only the +4, -4 will not consider since it is a distance. And the next diagonal is a DB. So D is a -3 comma 0 and B is the 1 comma 0. So distance of DB is equal to square root of 1 -3 minus or minus +3, it's become 4 square plus 0 is a 0, 0 square. The 4 square is a 16, square root of 16 is a 4 units. Yes, diagonals is also same. So the given quadrilateral is a square, right? Since they ask the reason, right? Give reason for your answer. Therefore, all sides are equal. equal and diagonals are equal, the given points are square.